more than one-third of the greenhouse emissions come from the building sector. Therefore, a big step ahead for facing the climate change should be improving the energy efficiency of the buildings.
Among others, in the early 80s, the first examples of self-sufficient houses, super-insulated houses, and solar houses started to be built around the world. Then, roughly 30 years ago, somebody came with a very challenging idea: heating a house with no active mechanical systems, thus saving natural resources, having the highest indoor comfort in terms of temperature, humidity, and indoor air quality. Living in a house with very limited operational and maintenance costs, with overall energy costs for a 150 square meters house ranging around 150 to 200 euros per year. The name of this person is Wolfgang Feist, and in 1989 he developed what he called the Passivhaus concept. This kind of buildings get the free heat coming from the sun. Therefore, the very high quality windows become a sort of natural radiator in winter. The Passivhaus buildings are so well insulated that in the coldest day of the year could be heated up with just 30 tea candles or just one hair dryer. Excellent comfort conditions are also met in summer by shading the windows and letting the heat outside the thermal envelope with almost no energy consumption.
It is proven that more than 94% of the persons living in such a building are fully satisfied with the comfort, corresponding to the highest comfort class A according to the ASHRAE classification.
Since then on, several million square meters have been built across the globe following this building standard. Not only does Passivhaus provide the highest comfort conditions to the occupants and the most cost-optimal building opportunities, but also a huge reduction of CO2 in the atmosphere may be achieved.
A Passivhaus building can be realized following the so-called 5 Passivhaus pillars.
1. A good thermal insulation, which prevents thermal losses in winter as well as undesired thermal loads in summer. 2. High quality windows optimized for the specific climatic zone. 3. Thermal breach-free construction. 4. A very high level of airtightness in order to avoid mold growth and uncontrolled and unpleasant air draughts through the leakages of the building envelope. 5. And finally, mechanical ventilation with heat or humidity recovery or single flux ventilation units according to the climatic requirements. The air circulates from the air inlets to the extraction valves while providing an excellent air quality to the occupants. In principle, all building typologies can be built or refurbished with the Passivhaus standard. Residential or non-residential examples including offices, museums, swimming pools, schools, churches, grocery stores, hotels, banks, and many others. In particular, in the past years, our company Zero Energy and Passivhaus Institute for Research shortly Zephyr, has been working on different projects in Italy and in several parts of the world, including developing countries, fostering a low-cost building approach which maximizes the ratio between comfort and costs. Our unique methodology combines the Passivhaus calculation program with a specific economic analysis in order to pursue the cost optimum for the project.
Under the motto, if you do it right, is meant that a suboptimal energy level would only limit the economic viability for further improvements, both on the thermal envelope as well as on the mechanical services. All of us should then grab the opportunity to invest on the best possible solutions and choose the Passivhaus standard. Tons of testimonials around the world show the benefits of this approach and express the tenants' satisfaction for the interior comfort and the extremely reduced energy bills. Don't miss your chance. Choose Passivhaus.
Zephyr, your partner for Passivhaus worldwide.